Yellowstone National Park is one of America's most treasured places. It's home to more than half the world's active geysers, has more than its share of bears and wolves, and it sits atop what may be the largest supervolcano on the planet. But despite its natural beauty, its danger is impossible to ignore. While the biggest threat to the park's visitors isn't exactly new news, there are other threats that may be even scarier. Hello and welcome to my channel. Today we're looking at Yellowstone Supervolcano, and I'll bet you don't even need me to tell you that's a big deal. I mean, have you seen the movie Yellowstone? You didn't see that. Well, if you haven't, stop watching this video right now and go watch that movie. Then come back here and let's talk about it. First, some basics. The Yellowstone Supervolcano isn't actually one volcano. It's three: the Norris, the Middle, and the South. Together, they form the Yellowstone caldera, which is also known as the Greater Yellowstone Supervolcano. But the name doesn't really matter because it's all connected and their combined magma chamber covers an area of nearly 500 square miles, which is roughly the size of Los Angeles County or the entire country of Tonga. The real danger with Yellowstone lies in its history. Over the last 2 million years, the supervolcano has erupted not once, not twice, but 3 times. In fact, the youngest of those eruptions happened only 640,000 years ago. That's a big part of why the area surrounding the park is riddled with super hot springs and geysers. And it's also the reason why scientists classify Yellowstone as an active volcano. The U.S. Geological Survey monitors it closely and issues regular updates about its activity. Good thing too, because while it's unlikely to erupt soon, when it does blow, things are going to get bad. Let's say it erupts tomorrow. Here's what would happen. First, people living near the park would need to evacuate immediately, obviously. But unlike in most volcanic eruptions, there'd be no warning. Yellowstone wouldn't just spew lava. It would also eject tons of ash into the air. So it would rain down over much of the western U.S. Unlike other volcanoes, thousands of square miles would be buried in debris, destroying everything in its path. Earthquakes would shake the region as the massive amount of underground magma chambers are emptied out. Most people in the immediate vicinity would have no chance of survival. But that's not where the danger ends. Buried under all that ash would be pyroclastic flows, superheated avalanches of rock, ash and gases traveling at up to 200 miles per hour. They could travel dozens of miles from the original eruption site, destroying everything in their path. Ash would blanket entire cities, collapsing buildings and burying infrastructure under tons of debris. And that's just in the first few days after the eruption. In the weeks and months following the eruption, a different kind of danger would emerge. With so much ash blocking sunlight, temperatures around the world would plummet, possibly triggering an ice age. All told, hundreds of thousands of people would likely die. But hey, at least global warming would take a little break. Okay, yeah, it would be pretty terrible. Now that was a worst-case scenario, but how likely is it to happen anytime soon? According to the USGS, it's pretty unlikely. They estimate there's a 1 in 730,000 chance of a major Yellowstone eruption in the next 30 years. But just because it hasn't happened in over 500,000 years doesn't mean we should let our guard down. Scientists recently discovered that Yellowstone's magma chamber isn't refilling like they thought it was. Instead, it seems to be shrinking, meaning the magma is coming from somewhere else, somewhere deeper inside the Earth. So what's happening down there? Well, it helps to understand how magma forms in the first place. Deep inside the Earth, rocks are incredibly hot, thanks to the intense pressure and friction generated by the planet's constantly moving tectonic plates. As these rocks heat up, they eventually become so hot that they turn into magma. Now, magma is less dense than the solid rock surrounding it, so it begins to rise toward the surface. Eventually, the magma reaches the Earth's crust, at which point it's either absorbed into pre-existing magma chambers, or it forces its way up to create a brand new one. This process happens all the time all over the world, creating pockets of molten rock beneath the Earth's crust. And those pockets often wind up being home to volcanoes. With Yellowstone, though, there's a lot more going on below the surface. Beneath the magma chambers you've already heard me talk about are a couple more, one at about 10 kilometers below the surface, and another at about 20 kilometers below the surface, but those aren't the only ones. There's also a massive low-temperature magma reservoir stretching for 90 kilometers beneath the eastern Snake River Plain. These deeper magma chambers are responsible for the constant supply of magma fueling Yellowstone's eruptions. Now, we know all this because in the early 1980s, scientists discovered something odd. They were expecting to find hotspots scattered randomly throughout the Earth's crust beneath Yellowstone, but instead they found a continuous band of heat running beneath the entire park. So what does that mean? Well, since then, researchers have used various techniques to better map the temperature and composition of the rock beneath Yellowstone. Their findings led them to conclude that there's a huge mantle plume, basically a giant column of unusually hot rock rising from deep within the Earth's mantle, supplying the magma needed for the supervolcano's eruptions. In fact, it might actually be two separate plumes. One study published in 2016 proposed that there are two discrete magma sources beneath Yellowstone, each with its own plume, one located 50 kilometers beneath the northern part of the park and the other beneath the southern part. Each plume would have the ability to generate its own super eruption, and while the one in the south has been largely inactive for quite some time, the one in the north appears to be getting active again. You see, the northern plume went quiet about 13 million years ago, but it began heating up again around 130,000 years ago. Researchers believe that it reignited due to the movement of the North American and Pacific tectonic plates. Basically, the plates are sliding past each other and the friction generated enough heat to activate the plume once again. And with it, the northern magma chamber began to fill up, forcing magma into the shallower chambers, where it's created Yellowstone's famous geysers and hot springs. And if the northern plume is reactivated, well, that means the risk of a super eruption is higher than we thought. But that's not the only recent development that's got scientists worried. See, the magma beneath Yellowstone isn't just sitting still, it's actually slowly moving in a circular pattern, rotating counterclockwise at about 2 inches or 5 centimeters per year. And it's been doing this for a long time, hundreds of thousands of years. But in the last couple decades, something changed. In the late 1980s, scientists noticed that the magma began moving faster, speeding up to almost 3 inches or 7.5 centimeters per year. And while that doesn't sound like much, it's actually pretty significant. It's possible that the magma chamber is being reshaped in anticipation of an upcoming eruption, which could be triggered by the movement of tectonic plates or the reactivation of one of the deeper magma plumes. Then there's the issue of earthquakes. The truth is, the ground beneath Yellowstone is always rumbling a bit. Because the North American and Pacific plates are sliding past each other, small earthquakes happen all the time. Most of them are too weak to feel, but occasionally there are larger ones. In 1985, for example, a magnitude 7.3 earthquake struck near Yellowstone, causing millions of dollars in property damage. While the earthquake itself wasn't particularly strong, it caused so much damage because of how shallow it was. It was only about 12 kilometers deep. Because of how shallow the earthquake was, the impact was felt over a large area. People as far away as Montana, Idaho, and Utah felt the earth rumble beneath their feet. Even worse, it activated a number of the park's geysers and hot springs, sending scalding water spraying into the air. And that's not good because, well, there's a lot of people who visit Yellowstone every year. In 2021 alone, more than 4 million people visited the park to experience its natural beauty, which includes its Old Faithful geyser, which famously erupts every 90 minutes or so. Of course, there are other animals to see, like bison, elk, wolves, and bears, lots and lots of bears. And it's not just a day trip. Most visitors stay for several days, giving them plenty of opportunities to, well, die. See, every year people die at Yellowstone, mostly from bear attacks. Since the park opened to the public in 1872, more than 16 people have been killed by bears and more than 200 injured. To put that in perspective, between 2000 and 2020, there were only 8 boating fatalities on the entire Mississippi River. And yet bears are only one potential problem. It's not uncommon for people to get lost, injured, or even die trying to take the perfect picture. Others die from heart attacks or strokes brought on by the park's thin air. Still others die because they fell into one of the park's many hot springs or geysers. Remember that earthquake I talked about earlier? Well, it caused several geysers and hot springs to overflow, killing one unlucky camper who was caught off guard. Another person died after slipping and falling into a hot spring. And in 2016, a man was killed when the ground beneath him collapsed and sent him plummeting into a boiling hot geyser. But maybe most impressive of all is that in 1988, the largest wildfire in the park's history burned over 790 square miles of land. Yellowstone is a beautiful place, but it's also unforgiving, and that's why it's important to monitor its supervolcano closely. Researchers continue to use seismic sensors to monitor any rumblings beneath the surface. At the same time, they're mapping the shape of the magma chambers in even greater detail. That way they can keep an eye on how the magma is moving and whether anything changes. It's hard work, but somebody's got to do it. Thanks for watching this episode. If you liked it, be sure to follow for more fun science stuff. Thanks for watching.